We're talking about a game changer. A game changer that's going to change the landscape. But just as we once made a dramatic shift from making dooms to making automobiles, something massive is happening at Toyota. A breakthrough so disruptive that it could collapse everything we know about electric vehicles. We have a very good relationship with Toyota, Elon Musk once said, and they're a significant shareholder in Tesla. Patents are being filed. Prototypes are being tested under complete secrecy. And at the center of it all, a bold claim from Toyota's own CEO that this could be the beginning of the end for the entire EV industry. Why is he so confident, though? Let's find out. The silent revolution's limits. The whispers started subtly, a murmur in the auto world. Then the rumblings grew louder, culminating in a statement so bold, so seemingly audacious, it sent shockwaves through the entire industry. Toyota's CEO stepped forward with a claim that many dismissed as impossible, a declaration that promised to rewrite the rules of the road. Our new engine will end electric cars. A stunning announcement, don't you think? This is why before we get to that earth-shattering revelation, before we dissect the technology and the implications of this audacious claim, we must first understand the web of factors that led to this moment. When we talk about electric vehicles, we often celebrate them as the future, clean, green, and endlessly progressive. But beneath the shiny exteriors and zero-emission claims lies a silent revolution, one that quietly fuels the electric dream. And at the core of this revolution, rare earth elements, some of the most crucial yet under-discussed resources of our time. Let's start with magnets. The heart of every high-performance electric motor beats thanks to permanent magnets made with elements like neodymium, praseodymium, dysprosium, and terbium. These aren't household names, but without them, your Tesla wouldn't glide down the freeway. These rare piles of earth create powerful magnetic fields in compact spaces, giving electric motors their impressive torque and efficiency. Alternatives exist, but they're heavier, less efficient, and far more expensive for mass market adoption. In other words, the rare earth solution isn't just convenient. Right now, it's essential. But here's the catch. Over 85% of global rare earth processing is currently handled by a single country, China. That's not just a number. It's a strategic chokehold. China has not only dominated mining operations within its own borders, but also controls critical refining capacity even for rare earths mined elsewhere. Australia might have rocks. The US might dig a few holes. But when it comes to turning raw or into something usable, that funnel narrows sharply, and China holds the spigot. And it gets even more complicated. China has implemented export quotas, tightened environmental restrictions, and even hinted at strategic supply curbs in response to international tensions. The global EV industry, despite its forward-looking message, is, in many ways, built on geopolitical sand. The dependence is so severe that even a modest disruption, whether from trade wars, environmental policy shifts, or global conflicts, could ripple through the EV supply chain like an earthquake. And then there's the price tag. Rare earth markets are notoriously volatile. Between 2010 and 2011, prices for neodymium and dysprosium skyrocketed by over 750% in some cases, after China slashed export quotas. Automakers were thrown into a frenzy. Governments scrambled to reevaluate their supply chains. The rare earth market has stabilized since then, but it's far from predictable. The fear of another price shock constantly hangs overhead. Although the true cost isn't just measured in dollars. Rare earth mining is messy. Extraction often leads to toxic wastewater contamination and even radioactive byproducts. In regions like Inner Mongolia, entire landscapes have been scarred by mining operations. Rivers have been poisoned, farmlands ruined, entire communities displaced. There's a dark irony in calling electric vehicles clean while their components are pulled from the earth in ways that devastate ecosystems and labor. That's a whole other layer. In parts of the world where mining takes place, particularly in less regulated regions, there are troubling reports of unsafe working conditions, low wages, and exploitative practices. In the race to electrify, many consumers are unknowingly supporting supply chains that are anything but ethical. So what's the alternative? Several countries are racing to diversify supply. The U.S. has designated rare earths as critical minerals and is investing in new mining and processing projects in places like California and Australia. There's even growing interest in deep-sea mining, where rare earth deposits lie scattered on the ocean floor. But these options are not only expensive, they're years, possibly decades, away from being scalable. And each comes with its own set of environmental and ethical concerns. There's also the idea of recycling rare earths from old electronics, motors, and batteries. It's promising. It's green. But today, it's only scratching the surface of what's needed to meet the exponential demand. Recycling rates remain low, and the infrastructure to support large-scale recovery is still underdeveloped. And that raises a bigger question, one we rarely ask: is this really sustainable? The narrative around EVs is often presented as a simple switch from gasoline to electric, from pollution to purity. But that binary thinking overlooks the vast and messy industrial machine humming behind the scenes. Yes, electric vehicles reduce tailpipe emissions, but the journey from mine to motor, from mineral to motion, reveals a far more complicated environmental ledger. Which brings us to Toyota. For decades, this company has taken a different path, championing hybrid vehicles instead of diving headfirst into the full EV race. Critics once called it cautious. Now it looks like foresight. Toyota's long-standing strategy may have been shaped by an early recognition of these very challenges: the resource bottlenecks, the geopolitical dependence, and the inconvenient truths hidden beneath the EV portrayal. They didn't just hedge their bets, they saw the writing on the wall. And as we look ahead, the race toward a zero-emissions future won't be won solely by charging stations and lithium-ion batteries. It will require innovation that solves the core problems, not just shifts them around. Because if we dig just a little deeper, it becomes evident that the electric revolution, as it stands today, is resting on unstable ground. That leads us to the next problem, a different kind of weight that's holding EVs back, quite literally. Let's talk about the battery. The weight of the battery. Today's most advanced lithium-ion batteries offer an energy density of around 250 to 300 Wh per kilogram. That might sound impressive until you compare it to traditional gasoline, which packs over 12,000 Wh per kilo. Even accounting for the inefficiencies of internal combustion engines, the difference remains staggering. You need several hundred kilograms of batteries to match the energy output of a single tank of gas.